Hey, Alan, I was wondering if you might be able to help me. I wanted to understand better the conversation that you were having on Twitter with that CERN physicist, and I was having some trouble following it when you guys were talking about Aries.
Oh yeah, the CERN physicist on Twitter who was discussing Airy's failure with me over the past couple of weeks with Pizio and I.
Yeah, that conversation. It's I've been reading along, and it just he seems to be all over the place. And just if you could possibly give some clarification. What was the premise of Aries' failure? Like, I thought it was to test the ether.
Absolutely. So that's a common misconception that'll be used to kind of shield the results of Airy's failure from the contradiction that the Earth is in motion. Now, the premise of the experiment dates back to 1862 with a guy named Professor Klinkerfuse, a German physicist, who was using the ratio of stellar aberration and his telescope, filling it with turpentine to measure an angle difference that would increase proportionally to Earth's assumed velocity and to the refract and as a function of the refractive index, meaning how long it takes light to slow down in the tube. The Earth would move out from underneath it, and that would cause the angle to increase. So this man said
So,
that he measured that.
so Klinkerfuse says he measured that back in 1852 with, you're
62.
saying
Yep.
turpentine?
Yeah.
1862.
Yep. He filled his telescope with turpentine and wrote a paper on it and basically laid out how, because the Earth is in motion and this is a dynamic effect, this is an effect that is present. Like, it's not something you can treat kinematically where it could be in motion or something could be in motion relative to it moving towards it. Because this goes back to the original measurement of aberration to start us off with before we get to Klinkerfuse. It goes all the way back to 1727 with James Bradley, where he was taking zenith measurements of a telescope and found that there was a deviation from the expected position over the course of a year that, when you add it all up together, adds up to about 20.5 arc seconds. And when you ratio that angle over the speed of light, you get 30 kilometers a second. And vice versa, when you algebraically do it to solve for what the angle would be with a V over C ratio, you get 20.5 arc seconds. So at the time, they took this as good agreement that they had substantiated their belief system that the Earth is in motion around the sun, specifically to the tune of 30 kilometers a second, because everything had to be compatible with Kepler's laws. Are you familiar with Kepler's laws?
Slightly, but will you go over them for me?
Yeah. So the first two are about the dimensions of an ellipse, and the primary one that we're concerned with is the ratio of the periodicity being proportional to the cube of the semi-major axis. So the periodicity squared is proportional to the cube of the semi-major axis. And this is important because when you're watching a planet complete an orbit, meaning, take the sun, for example, it takes 365 days for the sun to complete to return back to the same position that it was at in the sky. So you could say that is the periodicity of the sun is 365 days. So you can apply that to all the moving stars, or, wandering stars, or planets, as you call them. And you could ratio these things out, based off of how long it takes them to complete their orbit. And you could ratio that against pi and get an actual distance for their orbital diameter. And he was asserting through the geometry of an ellipse that the periodicity squared would be proportional to the cube of the semi-major axis. And the semi-major axis of an ellipse is basically like the radius of the ellipse. So if you extrapolate that out, you would be able to get distances out of that. And they built a whole model off of that, which comports to specific velocities so that all their planets at their different distances will make their respective orbits completed over that period of time. And that gives them a velocity and a distance to conceptualize. Does that make sense?
So they basically created these velocities and these distances from
Yeah,
the ratios
from the
of
ratio,
the
right?
periodicities. So they weren't, so we have no clue of these distances or of the velocity. But because of the periodicities that were observed, so the observations of these objects moving through the sky back to their original place. So we're taking these periodicities and they created the velocities and these distances,
That is
basically,
exactly
is what you're telling.
That's exactly right.
Okay.
They don't have to have any sort of physical meaning, but because you can ratio the periodicity against the constant like that, and the constant being um, the radius of a circle, then that'll tell you how big the circle is, right? So it doesn't necessarily even have to correspond to anything physically meaningful for dimension wise, but it would give you those values if they existed. Does that make sense?
Yes.
Cool. Okay, so in addition to that, they took it a step further and they introduced Newtonian dynamics to the sky, because the first ratio was just purely kinematics, meaning it's just observation and it can't tell you if the sun is moving around the earth, for example, or if the earth is moving around the sun.
Just that motion was at play.
Just that there
So we
was
didn't
some
know
motion.
what was,
Yep.
okay.
Yeah, because in
We
kinematics,
didn't know
relative
what was
motion is
moving.
true. Yep. Exactly. So when they asserted Newtonian dynamics into the equations, what you end up with is GMM over R squared, which is simply stating that the gravitational potential, the gravitational force, is equal to the mass of the two bodies over R squared, which is going to be like the how it's going, like the distribution of the strength of that gradient, like how much it's going to fall off as you get further away from the sphere. So
Okay.
now when they applied those, they also gave the same proportionality to Kepler's laws, and they took that as agreement that they had come up with a dynamic prediction of motion based off of the force of the gravitational potential between the two bodies based on their masses, and then the mass giving them the inherent property of gravitational attraction, which is said to produce the velocity that all these planets are moving at. And because the velocities work with Kepler's laws and the masses work out and all that with the gravitational potential ratio, they took that as physically meaningful. That was like the step up from, okay, we have these laws that are mathematical, could be physically meaningless, to now we're making a dynamic prediction with an equation that has forces in it. Because when you're talking forces, you're talking dynamics, which is a separate part of physics where you're making predictions of future motion based on forces.
Right. And once we've introduced these forces, that's where they have come up with, where we've introduced the gravitational force, we've introduced the mass, and now they've coming up with what they're saying is dynamic causes, and
Exactly.
how these planets are actually causing the motion from their weight and their path in orbit,
Yes.
like being pulled by the sun. Okay. But
Yep.
this has all been computed.
So
But up to
far,
this point, we've been computing everything.
yes.
Okay.
So far, 0 people have put a scale on a planet and weighed it or anything, or put a speedometer on it and measured its velocity or something like that. They just have the observation and the ratios. So the interesting thing about Newtonian dynamics as applied to the sky, though, is that the mass in the equation cancels out, because remember it was GMM over R squared. So if you cancel out the m's in the equation, because it's algebra, you can cancel out the things that are the same. If you cancel out those m's, you're just left with the ratio of periodicity over big G. So the reason
Wow.
the reason it shares that same proportionality ratio with Kepler's laws is because there's no actual dynamics inserted into it, and it's kind of like illusory. Because when you
It
add,
seems a lot like illusory.
yeah,
Illusory forest. Like they just invented this whole system and the
yeah,
connection to it. Yeah.
yeah, because when you add the mass back in, for example, if you were doing the orbit of Jupiter's moons around Jupiter, well, if you put the mass of Jupiter back in and you put the mass of the moon back in, of whatever you're trying to calculate the periodicity for, the it changes the equation by 0.1%. It makes no difference. It's completely irrelevant. So,
Is an irrelevant factor.
right.
But yet they want to claim it's okay.
Yeah.
Math magic at play.
Yeah, so you can kind of see now where it's like, because of the presentation of how the equation is written, it's taken as physically meaningful. Although when you work it out, the thing that you interpret as physically meaningful is the least important part.
It means so little. All right. Well,
Right.
thanks.
And
We got that figured out.
yeah. And so with
We
that,
can cancel out that mass. All righty.
yeah, you just not necessary. So with that said, there was a couple of experiments that were done that tried to substantiate Earth's orbital velocity, and we're going to go over those now. Now, the first guy to try and do it, his name was Arago, and his method of experiment was to half cover his telescope with a crystal prism, so that when starlight intersected the midpoint of it, if the Earth were in motion, because the starlight was slowed down in the crystal prism, it would now um, it would now look distorted in the through the telescope, and you would have to kind of tilt the telescope a little bit to keep it in the center, is what his hypothesis was, if the Earth were in motion. And what he found was the refractive index of a fixed prism is the same for a quote unquote moving prism. If you assume that the Earth is in motion, that would be your moving prism. And those two values actually can't give the same angle if the Earth is in motion.
But he tried to say that they were the same.
Well, they measured them the same, and the implication is that the Earth is stationary and the starlight already comes in at an angle. And this was noted as such because people had to try to explain this experiment through the paradigm, because at the time it had been realized that light slows down in a medium, and you can use that to make measurements of the properties of that medium. So when they started measuring refractive indexes of translucent medias, this was all based off of the timing difference in the speed of light, which was measured by interference pattern. So it was pretty damning, in other words, because they knew like exactly, like
Yeah.
they knew what the outcome had to be.
Right, and it showed and it showed the same. So it was basically showing that there was no motion of Earth, but they didn't want to accept it.
Right. It shows that the starlight already comes in at an apparent angle, and there's no true position of them, so to speak, because the whole ratio of aberration to begin with is dependent on a snapshot of the sky at a particular time of year. And then when the stars don't move quite as predicted, they've incorporated this 20.5 arcsecond ratio as like their velocity component, but it could also be physically meaningless. So this is kind of like granting aberration as proof of the model, and like kind of like in like exploring the implications of it is kind of like stepping into a thought experiment and giving like full benefit of the doubt to what's being discussed, even though it could be, the implication is that the sky is doing it and not the Earth.
So there's the implication there that it could be the sky doing it and not the Earth. But we're not going to wrap our arms around this yet and embrace it, because heaven forbid we could throw everything else out.
Yeah,
okay.
we don't have to embrace it quite yet.
So how do they move forward from this? So he's got the light coming through, it's got the prism. He's showing that it's already coming in at an angle. So then where do we go?
So where we go from here is radio silence for the next 20 years-ish, I think. And then Airy comes along to help out after another gentleman named Professor Clinkerfuse did the same experiment that that Arago did, except in his experiment he used turpentine to fill his telescope with water instead of using a prism.
And so we've got now a telescope filled with turpentine, and this was clinker fuge.
Yeah,
Okay.
so a German physicist in
And that's floating.
1860, I'm sorry, a German physicist in 1862 was taking zenith measurements of stars with a telescope filled with turpentine in the same way that Bradley was taking the measurements in air. The idea here was, again, if you fill the telescope with if you put a medium between the starlight and your eyepiece, the slowing of the starlight to meet your eye will deviate as your physical position in three-dimensional space changes, because the Earth would have to be in motion around the sun to complete its orbit if the interpretation of the ratios was correct, following Kepler's laws and Newtonian dynamics applied to the sky.
And yet he didn't measure. He didn't have to tilt the telescope.
So it's really interesting because Professor Klinkerfuse made the claim that he did make the measurement and that it did increase to 20 point, what was it? I think it was 20.5 arc seconds. So he said that he did get the increase, which would be massively substantial, which would be a massive substantiation for the heliocentrist, which is dependent upon, Earth's velocity, if the correctness of Kepler's laws and Newton's laws are to be asserted.
So Klinkerfuse says he did measure it in the turpentine telescope.
That's what he said.
What about ether? So how does that affect the ether?
Yeah, that's a great question. So Klinkerfuse specifically stated in the book that he wrote about this, that independent of any ether effects or any ether models, because the primary ether theory at the time was that the ether was static, they didn't really like the idea that the ether was dynamic, meaning that it had motion to it, because the ether would be co-moving with the Earth, and that would interfere with things like the constancy of the speed of light, and that would basically ruin using the speed of light as a constant and then applying that as a yardstick to the sky for astronomical purposes. Because if you can't verify its constancy on Earth, how could you assert it in the sky, right? So they didn't like the idea that it was co-moving, so they tried to avoid that, and they kind of kept their interpretation to the ether being static and immobile, and everything moved through it. And specifically for Klinkerfuse, he was saying that independent of any ether theories, though, because the Earth is in motion and refractive indexes are not dependent on any ether mechanics or anything like that, that there has to be an angle change increase, based off of cosines and refraction.
So there should be the angle change increase, is what he was saying.
Regardless of any ether.
Measured it. Regardless of an ether.
Yep. Yeah, and additionally, there was the hypothesis of Fresnel drag, which was experimentally measured by Fresnel in the 1850s. And the hypothesis was that the ether, being static, could be dragged by a moving material medium, and that would affect light propagation, retarding it or accelerating it, depending on whether or not it's moving with the direction of the moving medium or not. And that was experimentally, and the ratio to that would be over n squared. And so what they measured with that was that there was an 88% translation of velocity to the light in the form of acceleration and retardation going with and against the flow of water through an interferometer. And that, so Klinkerfuse noted that, although his hypothesis was independent of any ether effects, there could be some ether effects due to the dragging of light in a moving medium. And if you were to assume that the Earth is in motion, right, although it appears stationary from our reference frame, it would technically be a moving medium. So there could potentially be an 88% velocity ratio, or it would be 44% for the first part of the year, and then 44% against going in the for the latter part of the year, so 88% total. But anyway, in other words, he was saying that there should be some effect, so like not to fully discount ether from it, but in terms of calculating it and using it as a mechanic in his derivation, there's no ether variables in his math. It's all Snell's law, cosines, and the speed of light.
Okay. So that brings us then to Airy's and his water-filled telescope, right? Trying to figure out, you know, where do we stand with the ether, and is it there? Is it moving?
Absolutely. That's exactly where it brings us. Because Clinkerfuse was such a man of repute, Airy's had to confirm this for himself, because at the time, especially with realizing that you could use light to make measurements of absolute velocity, this was a pressing issue, because this was going to be confirmation of of everything that they had been asserting mathematically as applied to the sky. So Airy was like, hey, I need to confirm this as well. So he commissioned his Zenith mount to be built, and he started taking his own Zenith measurements of stars, Gamma Draconis to be specific, at the observatory in Greenwich, where he used a water-filled telescope to make measurements. So what he started with was a micrometer screen, which is basically little thin wires that are 1/1,000,000th of a meter long or wide. And he made a grid out of those, put it over his eyepiece, looked up at a star, and measured its position, and then using a swivel, rotated his telescope 180 degrees and took the same measurement to make sure that it was, that there was like no changes or no errors or anything like that. And he could take the difference of the two to like zero out any mistakes and stuff. So he had an insanely precise way to measure arc seconds in the sky to 1/1,000,000th of a meter on the ground using the micrometer setup. And through that, he was able to establish their positions versus their idealized true position, and make his aberration measurements in air versus in water.
So you said that he would flip the telescope 180 and take the measurement again. So like he flips it completely upside down?
Oh, no, sorry. By flipping, I meant he rotates it on a horizontal axis. So there's a vertical spindle that the telescope can move left to right on, essentially 180 degrees to itself on the horizontal axis.
Gotcha.
So yeah, it actually doesn't tilt at all or flip. It only
Right.
it remains
Because it's a zenith mount. So when we're spinning it 180.
Yeah.
Not flip. So when we flip, we're okay.
Correct. Correct. And yeah, so he took his measurements, and when you look at his data set, he found that the aberration in air is the same as it is in water, which is a huge contradiction to the predictions made by Clinkerfuse, because when you math out what the angle increase should be using cosines and Snell's law and velocity addition, you would get 27.5 arc seconds as an increase. So it would change from 20 arc seconds in air to 27.5 in water was the predicted angle change, and there was no change measure.
So they predicted they should have that angle change of 27 from 20, and there was none.
Correct.
So, and Airy's did this over and over and over again, and continually found that there was no change.
Correct. Did repeated measurements throughout the year and found no change.
So are there current methods of velocity addition?
Yeah. So the way that you make the prediction using Snell's law and the assumed velocities and stuff, that will give you 27.5 arc seconds. And the current paradigm is, that relativity is correct and that the speed of light is constant. And based off of the rules for relativistic velocity addition, they actually make the exact same prediction for 20.5 arc seconds, and then down to 2/10 millionths of a degree is what they is where they differ. So, and they differ to that degree because the only difference between the velocity addition classically and relativistically is they add a gamma factor to the equation, which is basically they're multiplying by v squared over c squared at the end of it, which gives you a really, really, really tiny change, because all you're doing is using a small numerator and a very large denominator, which is going to give you a really, really small outcome for your difference. And that effect isn't measurable, right? We can't measure anything down to 2/10 millionths of a degree like that. So the only physically meaningful part of the equation is like the classical derivation, which is what relativity has to use to be in agreement with reality. So both theories make the same prediction and they use the same velocity composition laws, except for, one doesn't have the gamma factor, but that's just a really tiny term that's actually neglected. You can just treat it as not even being there, to be honest with you. And so that's where we run into problems with the modern day explanations, because there's no real good explanation for this when you get into the predictions versus the measurements, right? Because we have the official relativistic prediction, which agrees with the classic, which is done by dividing the velocity over the speed of light over the refractive index of a medium that the light is propagating in, and that properly gives you the first order timing difference in the speed of light to cause that angle change, to cause that ratio to be different. We have this ratio that we're using for V over C. So we're invoking several things here. We're invoking a first order difference, first order timing difference. And we're also using a ratio over the speed of light, which is equivalent to defining a preferred reference frame, right? Like mathematically speaking, if you're referencing a velocity against another velocity as a constant, and you're going to use that for, all velocities, well, you can kind of conceptualize that as using light in its own reference frame where it travels at that velocity, although it may not necessarily measure that in reality. You're using that as a fixed point of reference for all motion to be relative to, which is also antithetical to the current mainstream paradigm of relativity theory. And then the first order timing difference, showing that the speed of light is not constant.
What do you mean by a first order timing difference?
Well, specifically, you can kind of think of it in several different ways, because there's different applications to the phrase first order, especially when it comes to chemistry and in physics and mathematics. So for mathematics, a first order would be the approximation. So it would be like a direct V over C ratio. And then if you were to do a second order approximation, which would just be a higher order, smaller numbers, right? You would use like V squared over C squared, for example. And for chemistry, a good way to think of it is in proportional ratios of a reaction. So if you have a chemical compound and you introduce another compound that's going to have a reaction to it, if the reaction is proportional to the compound that you put in, then you would say that that reaction is first order because it's directly proportional to what you introduced to cause the change. And then that change would be, proportional to that same ratio. So in terms of first order, you're typically speaking about the ratio of influence of something. So does that make sense?
Right. So the ratio of and what is affecting it immediately.
Exactly. So for first order timing difference in reference to light, you can kind of think of it like the Sagnac interferometer, where the timing difference that's measured through the fringe patterns is proportional to the square of the angular velocity of the rotating table. And when you without that first order timing difference, it wouldn't be proportional to the velocity. So if you were to speak on that in terms of first orders, you would say that the first order effect of angular rotation or velocity is being measured in the first order by these fringe shift patterns because the fringes are directly proportional to the velocity that caused them.
Okay. And their direct relationship to that.
Yeah, exactly. So usually it's like when something has a direct relationship with something, is an easy way to conceptualize it. And then in terms of relativity theory, where they introduced the gamma factor, which I talked about earlier, which is link contraction and time dilation. Link contraction and time dilation are a function of velocity squared over the speed of light squared, which is a really small number. So you would never have a direct first order timing difference. If relativity were true, you would measure, if you could measure these, you would only measure really tiny differences because they would be a function of the velocity squared over c squared.
Okay.
So yeah, it would never be directly proportional. Correct. And that's really important because that classic equation does agree with the relativistic one and vice versa, but the difference between them is that minuscule difference that can't be substantiated at all. So for all intents and purposes, the classical equation outweighs the relativistic one because you could never confirm the correctness of the difference between the two.
All right, because that's such a little amount from the current one. Okay.
Right.
So classical outweighs it.
Absolutely. And then and then in reference to using the light frame right now, people sometimes refer in the past especially refer to the ether as a preferred reference frame for measurement. So like they were thinking of it as a purely mathematical concept. And also it was conceptualized as a fluid. So go ahead.
Like when we're talking about the light frame here then, like when we're.
Yeah, when you do a V over C ratio, you could conceptualize that if you wanted to as a Cartesian coordinate system that the motion is being measured against.
All right.
And that's important because in the theory of relativity, they say that there is no preferred reference frame mathematically, and also that there is no medium of ether either. So the two interpretations of ether, like one being a mathematical reference frame to which you could measure all motion against, and secondly, as a mechanism, as a physical material medium necessary for electromagnetic propagation. Those things had to be removed to provide an answer for Airy's failure, to make a zenith measurement that corresponded to Earth's velocity when he introduced water to it. But so yeah, now we're going to get over. So now that we've seen how the two theories compare and contrast, now we have to look at the ad hoc custom interpretations that people give to try and rectify why both theories, classical and relativistic velocity composition, both predict the angle change, but one isn't measured.
Okay. So now it's how people go about trying to say, okay, so
Yeah.
what is it for the
Yeah.
mainstream?
Yeah. So there isn't really one for the mainstream other than invoking a reference frame change um, with respect to the sun. So they'll change their position to the position on the sun. And they'll say that if we were on the sun looking at an observer on the earth, we would see the angle change to 27.5 degrees. But but because we're in the moving frame, we don't see it that way. And that doesn't really make any sense.
It doesn't.
Because you're just kind of assuming the velocity on the back end and then transforming to another position and saying that it exists here, but not for us, where we're taking the measurement. And we could even do one further, where when we introduce the water medium, well, actually, before we get to that, that's where we're at with the transformation as the mainstream explanation tells it. Before we get into anything convoluted or like a deviation from the mainstream, we're just looking at the math that they provide for it in the transformation. So what they're asserting first is that the velocity, the unmeasured velocity, is assumed. And then when you assume it in a different reference frame, you could look at an observer on Earth seeing the difference, but you wouldn't be able to see it in your moving reference frame. So that's kind of how they justify that. And if you press further, that's where you get into the issues where, because it kind of falls apart from there, right?
Yeah, that doesn't even, I don't know, my brain has a hard time even comprehending how they can get away with saying that. So, okay.
Well, they can only really get away with it because they've convinced everyone that their mathematical framework that they're using, which is called covariance, when they do a transformation like that and it all works out, they take that as agreement that that it represents physical reality, even though it doesn't. That's, but they've been taught that, so they interpret that as, because we carried the 3 and did the math correctly, therefore it must exist correctly in reality.
Okay. Math magic.
Yeah, essentially. So looking at, I know it was probably hard to follow the Twitter timeline you were mentioning, because the arguments pivoted to 3 different arguments before we could get an argument locked into pen and paper with math. So I'll kind of briefly go over the two other arguments that were put forward and how it all comes down to the argument that was done in math, because that's what they ended up going with as the explanation.
All right.
So the first argument that was put forward was that we had to treat the incoming light as plane waves, which is an idealized calculation to treat the wave propagation. And then it was stated by the CERN physicist that when the light hits the water, then we can treat it as spherical waves. And the difference between the two is pretty much nothing, because of what was measured with Fresnel drag. We know that when light hits a moving medium, we know the exact relationship that it's going to have with how it's going to carry that velocity potential of the medium. And that was measured in 1851. So the math that he gave for the plane wave and the explanation contradicted Fresnel drag, or the measurements that were done by Fazal that supported Fresnel drag. So that interpretation of plane waves and treating it differently and yada yada is an invalid interpretation.
Invalid. Okay.
And the next up was that Snell's law already accounts for aberration. So here, the CERN physicist was kind of saying that because Snell's law accounted for refraction, there would be no angle change for aberration, which is a complete misinterpretation. That doesn't even like logically track, right? They're 2 separate phenomenon. One is the change in the velocity of light in a medium. The other is a ratio of a velocity over the speed of light, whether it be the speed in a vacuum or the changed speed due to a refractive index. They are not all, it's not an all-encompassing thing where you could say accounting for Snell's law also accounts for aberration. That doesn't logically track. Right. Or no. Mathematically.
And they but that's what he tried. That's what he was trying to do, is say, well, if I'm accounting for Snell's law, therefore I have accounted for aberration.
Yes.
But they're not mathematically
correct.
Complete. Okay.
And another explanation that was put forward was to do a custom interpretation of classical and relativistic velocity composition. And this was to do a vector velocity summation. And this was essentially transposing Earth's assumed velocity in the x-axis direction over to the incoming light in light's x-axis direction. So instead of having a star that's infinitely far away that you can consider stationary, that's sending in a parallel light ray that has no velocity component to it in the x direction, you're going to attach an x direction velocity component to it because you're assuming that the Earth is doing the same. And then when you do that, you actually predict no angle change. So to try and rectify the two, that explanation seemed appealing at the time, because when you transpose that velocity onto the incoming light, you would predict no angle change. But this creates several asymmetries in the mathematical framework.
So what are the asymmetries that it creates?
So the asymmetries that it creates are, one, just merely treating the Earth stationary mathematically does not remove its actual dynamic velocity component. I can treat the Earth as stationary all I want, but if the Earth is actually in motion to complete these periodicities, as stated by Kepler and Newton, then it has to be in motion, right? You can't just treat it as that. There's still going to be a dynamic effect. So when they treat the Earth as stationary, right, and they predict no angle change, what they're leaving out of the math is that the Earth is still in motion, and that is what is allowing there to be no angle change offset. Because if you were to truly treat the Earth as stationary and not keep that velocity component in the back of your head to cancel it out and make it give a null, you have to you would have the Earth being stationary, and you would have the light coming in with an additional velocity drift to it. And that would make the correct prediction, which would agree with the classical and relativistic velocity composition, where they're trying to add them together to get the 27.5 arc second thing. That would actually work. The only reason it doesn't work is because the Earth would still be in motion, has to still be in motion for there to be no actual change. So that is bankrupt as well. It doesn't work either.
No. So they're trying to cut out the motion of the Earth. Oh.
They're trying to cut out the motion while keeping it, while cutting it out.
That's so confusing.
It is confusing, and it's very hard to follow, but that is where it had to be taken because of the glaring contradiction. And it gets a step worse, because now that after running through these arguments for about, what has it been, 2 or 3 months now? Actually, it's been even a little longer if you want to go back to the OG argument of Fresnel drag and the telescope, and how that would have to have an angle change if light, or if the Earth were in motion. The current thing that we're looking at now is the acceleration of light mathematically. So the equations that Franco gave to try and give explanatory power for relativity and heliocentrism to make it so that the angle is the same, he actually gave an equation that accelerates the light and makes it decrease in angle. And we know that the angle decreased, or that we know that there was no angle decrease. It stayed the same. So even this interpretation is wrong, but for several reasons, which we'll go over here, in addition to the fact that that the decrease wasn't measured.
So his math showed that there should have been a decrease in the angle, and it was the same. So we know that whatever he's exploring there is not correct.
Yeah. So the math that he was using was, let me look it up real quick. It was the ratio he was using. Oops. All the way at the bottom here. So he was using he was using C times N over time, he was using V times N times V over C. And if you do that, you accelerate the light. That the implication there is that the light will accelerate proportional to the refractive index. So the N would be the refractive index of water. So he's saying that when the light hits the water, it accelerates. And to understand why this is so significant and wrong, other than the fact that it would break conservation laws, and you're just saying that it accelerates for some unknown reason when it hits the water, right? We go back to 1887, the Michelson-Morley paper, and I'm going to read a little bit from it so that we can see what happened over 100 years ago, why that was wrong, and why what is being done now that's asserted as correct is wrong. So 1887, On the Relative Motion of the Earth in the Luminiferous Ether by Albert Michelson and Edward Morley. The discovery of aberration of light was soon followed by an explanation according to emission theory. The effect was attributed to a simple composition of velocity of light with the velocity of Earth in its orbit. That's that V over C ratio, using V for the velocity of Earth over the velocity of light. The difficulties in the apparently sufficient explanation were overlooked until after an explanation on the undulatory of theory of light was proposed. So before they, when these measurements were done, there were two competing theories for how light propagated. One was that light was a corpuscle, and that was a little tiny ballistic bullet, you can think of it as, or the undulatory theory, which is that light is a wave propagating through a medium. Now, they said that the emission theory was wrong, and light doesn't travel as a little ballistic particle. And mathematically, what they were using to predict no angle change was the same ratio that the CERN physicist was using, where light accelerates when it hits the water medium. And so that was obviously wrong, and that wasn't noted until the wave theory came out, and they realized that the correct way to do the math was to do velocity divided by C over N, which reduces C by a factor of the refractive index, and that ratio will lower the speed of light to 0.75 of C. And that is how you do these measurements, because it creates a timing difference. And the only way to get a timing difference that makes sense, to what's measured, is to slow the light down. And you do that by putting N as the denominator in the denominator of the V over C over N. So we'll continue on now that we know what they did wrong and what they can do right, or what's done right, because it's what gives agreement now, right? So
Correct.
It goes on to say, but it failed to account for the fact proved by experiment that aberration was unchanged when observed in a telescope filled with water. So although they had corrected the way that they do the math, now neither theory can account for why the water is unchanged. And he goes on to say, for if the tangent of the angle of aberration is the ratio of the velocity of the Earth to the velocity of light, since the latter velocity in water is 3/4 the velocity in a vacuum, The aberration observed with a water telescope should be 4/3 its true value. Now, that's extremely significant because now that we have the proper way to do it and derive how much angles should change, which it should be that 27.5 arc seconds, we're wondering where our 20.5 arc seconds is, right? Because based off of these ratios, it should be very straightforward. So he goes on to add a cliff note where he says, it may be noticed that most writers admit the sufficiency of the explanation according to the emission theory, while in fact the difficulty is even greater according to the undulatory theory. So remember, one was a mathematical mishap. The next one is mathematical correctness, but the measurement doesn't agree with prediction. For the emission theory, the velocity of light must be greater in the water telescope, and therefore the angle of aberration should be less. Hence, in order to reduce it to its true value, we must make the absurd hypothesis that the motion of the water in the telescope carries the light in the opposite direction of motion.
Because they're still assuming that the Earth is in motion.
Yes, you would think that they would drop it, but they were committed to that Copernican philosophy. So yeah, if they were to hold their belief system as true, they now have the greater difficulty of explaining using some unknown mechanism as to why there's no angle change when there mathematically is predicted to be one given the circumstances of their beliefs.
And that light is moving in the opposite direction of motion once it hits the water.
Yeah,
that's just a crazy assertion.
That's what makes it double extra ridiculous. But so check this out. Earlier, when I was talking about how they conceptualized the ether as being static, they made an ad hoc exception to say that perhaps the ether in the moving telescope is bouncing around, and that bouncing around is carrying the light in the opposite direction of the velocity, which is obviously a massive stretch. But yeah, there's really nowhere to go from there, because it
doesn't seem like there would be.
No, it makes no sense, and it's contradictory to Fresnel's hypothesis, which was experimentally measured by Fazal, which is that light gets a velocity boost or retardation with an 88% proportional ratio, 44% going with, 44% going against. So at the bare minimum, there has to be an increase if the Earth's motion is the true cause of the aberration in the first place that was asserted.
So did Franco have any way of trying to justify any of this? Because it just seems like they've backed themselves into such a corner. How are they trying to justify it?
Yeah, so when I talked to the CERN physicist about that, he asked me where I got the equation from, as if that mattered at all. It gives the correct prediction. It's derived from the ratio relationship of the slowing of the speed of light in the medium over c squared, or over c. So it doesn't make any, like, his approach was just to kind of like question the validity of the equation. And we're talking about a person who once stated, when asked about the validity of Feynman diagrams and how Feynman could never explain how he even derived his equations or his diagrams and how they relate to one another, he simply said, this is Feynman, he simply said, well, my equation's correct, and because it's correct, that's how I know it's correct. He never gave an explanation of how he even derived it. And when I questioned the CERN physicist about that regarding quantum mechanics, he stated, quote, I don't care where the equation comes from. All I care is that it makes the correct prediction. So it's interesting to see that when the equation makes the correct prediction for the V over C relationship using the correct speed for the speed of light, not accelerating it, it's interesting that all of a sudden he wants to know the validity of where the equation came from. even though it's self-evident. that was his only way to kind of deal with it.
It doesn't seem like he dealt with it at all,
No,
though.
no,
He
yeah,
just
yeah, yeah. So only through fallacies, right? Only through fallacious reasoning, and then yeah, that's pretty much it. Because now that he committed to the math, and his math, one, makes the wrong angle prediction from what was measured, so it's not valid, and two, now that the valid um, math has been asserted, the angle change that's required still isn't measured. So the original position that was held the whole time, that the Earth is stationary with respect to a dynamic ether in the stars, and the sky moves above us essentially, um, has been unchanged by this entire interaction over the course of the last 3 or 4 months. Whereas we went through a series of arguments before one was committed to math, and then the math was wrong.
Well, how nice for the math to work out and show us that, the Earth isn't moving and that the starlight already comes in at an angle.
Sometimes the math is just the math, and the when that can't be refuted, you just you have to resort to never acknowledging it, and that is why modern physics hasn't progressed over the last 100 years. They've been stuck in a dead end contradictory theory based that's solely proposed to keep a philosophical preface alive.
Well, how sad for them. Modern physics should open up their brain cells and take in some new concepts. Like maybe we're not moving.
Yeah,
Maybe, just maybe, the Earth is stationary.
it would be nice to take that into consideration, since all dynamic predictions of motion start with a stationary, non-rotating Earth. Regardless of what shape you believe it is, the dynamic predictions of motion are based off of stationary, non-rotating, and that is the only frame that will make the correct prediction um, for energy conservation, for future motion, for everything. When you use a moving frame, you can show that that frame is invalid through dynamic analysis, either doing kinetic energy or some other form of energy, um, to determine the validity of the frame. And you could show that only the lab frame, stationary, non-rotating, makes the correct prediction every single time. And in fact, there's like a little experimental preface that that the Earth is a non-inertial reference frame, but for literally every experiment done, it's just inertial enough somehow that the movement, or annual through the orbit around the Earth, or sidereal, doesn't have any effect on uh, on experimental measurements, except for when you use light. You can measure sidereal rotation, based off of the minimum and maximum peaks in the fluctuation of the speed of light throughout the day, which is kind of weird because it's based off of the minimum and maximum peaks of a difference. So it would be like saying that the Earth is slowing down and speeding up, and then the change in position of the mirrors and the interferometer that's making the measurement is producing the change. But when you know that the velocity is to the square of the fringe pattern, well, now we have um, thousands of kilometers a second, um, rather than a rotational rate of 1,000 miles per hour at the equator, right? Like they're not what's measured, but the angular rotation rate, when you plot the min max peaks against sidereal time, they associate that as the confirmation of sidereal rotation in terms of an angular 15 degrees per hour, right? But not in the terms of a translational velocity component, which we know is perfectly valid to use through interferometric experiment from Ruyong Wang and some other people. So um, it's once you acknowledge the measurements, you can see that the Earth is stationary with respect to a dynamic ether that is translating motion from the sky, because that's why the sidereal periods match with the min-maximum peaks.
Sidereal time. All that motion in the sky. It would
Yep.
be nice if mainstream could figure that out, that we're stationary and that the motion is in the sky.
That the motion happens around us. It would be fantastic if they acknowledged that. But yeah, that's the recap on the conversation I was having on Twitter and the several arguments that were proposed and then the conclusion to it. And the conclusion turned out to be that the math was done incorrectly in such a way that we were actually reliving an argument from the 1800s because there is no
And
explanation.
Franco just proposed the same thing, but Airy said that couldn't be because the light would have to, or it would have to travel the opposite direction in the water, and that's just preposterous. And it's funny that he tried to present that to you as his argument on there. Walked himself right back into the trap.
Yeah, you can only really do what he's doing by like first gaslighting yourself and then gaslighting those around you. Because when you go through the math, it's pretty straightforward in the implications. So yeah, to protect his academic reputation and the Copernican principle philosophy, which has been handed down to us, you have to operate like this in such a way that you produce incoherent arguments that don't even give the correct measured value for what was measured, and then you just say that, like, you know, it's proof that you're in motion, and it's proof of the theory that you use to assert its correctness, even though it's literally not measured.
Well, thank you.
No worries. Thank you.
I think I understand better that he doesn't understand. And wow, it must be wonderful to be able to gaslight yourself like that.
Yeah. It's it's a real gift, I guess. It's the gift that keeps on giving. The self-gaslight. But like my boy Toby said, don't gaslight your own soul. Einstein lied.
I would have to agree.